Hi, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to discuss the problems on formation of partial differential equation. The partial differential equation can be formed in two ways: by eliminating arbitrary constants and by eliminating arbitrary functions. There are two methods. One is elimination of arbitrary constants and other one is elimination of arbitrary functions. So by eliminating these things, we can form the partial differential equation. And moreover, the partial differential equation is an equation which contains partial derivatives, or an equation which is having the differentials, the derivatives with respect to two or more variables is called a partial differential equation. Already we have seen in the previous video the definition and order, degree and some examples already we have seen in the previous video. Now we are going to solve some more problems on partial differential equation formation by eliminating arbitrary constants as well as arbitrary functions. Now, see the first problem. Form a partial differential equation by eliminating the arbitrary constants a comma b from the function given z is equal to ax plus by plus a square plus b square. We have to form the partial differential equation by eliminating the arbitrary constants. So how we will eliminate? So here we have two constants. So we need two equations to eliminate the constants. So first write the given equation. Z is equal to ax plus by plus a square plus b square. And to eliminate the constants, I would like to differentiate partially the above equation with respect to x as well as y. So on differentiating, you will get dou z by dou x. So a constant and x is differentiation 1. By it is completely the other variable because it is a variable y. And differentiating with respect to x, it will be 0. A square constant 0 and b square also constant, it is also 0. So dou z by dou x is equal to only a only, that is nothing but p. P means dou z by dou x. Already we have seen the notation. P means dou z by dou x and q means dou z by dou y. So dou z by dou x is equal to p is equal to e, and call this is equation number 2. Similarly, on differentiating partially with respect to y, dou z by dou y is equal to first term 0, third term 0, fourth term 0, only you will get b into 1, that is b. So dou z by dou y is equal to q, therefore q is equal to b. So we have two equations, the equations 2 and 3. Now substitute the equations 2 and 3 in equation 1 to get the required solution. So on putting these values of a and b in equation 1, we get z is equal to px. A for a is substituted by p and b is substituted by q. So z is equal to px plus qy plus p square plus q square, and which is a given required partial differential equation, which is the element of a comma b. There is no terms of a and b. Clearly it is a partial differential equation with respect to the given function. So here what is the observation means, to get the PDE partial differential equation, we have eliminated a, b from the relations 1, 2 and 3. And clearly this is the first order partial differential equation. The p means dou z by dou x, first order derivative, and q also dou z by dou y. So both are first order derivatives and these derivatives are involving in the equation. So it is a first order differential equation with the degree 2. It is dou z by dou x whole square. So the degree is also not 1, it is 2, right? So here I have given the small observation. If the number of constants to be eliminated is equal to number of independent variables, then the derived partial differential equation is of the first order. In the previous example, there are two independent variables x and y, and there are two constants to be eliminated, small a and small b. So the derived partial differential equation is of the first order. So already I told that in the previous example, this is the first order partial differential equation. So if the number of constants to be eliminated is 2 and the number of independent variables are 2, then the formed differential equation is of first order. So that is, because these two are equal, here it is 2, here it is 2, these two are equal. If it is Z, if it is C, then the differential equation obtained is a first order partial differential equation. The next observation, but suppose if the number of constants to be eliminated is greater than, suppose if the constants are 3 constants, A, B, C greater than, or suppose there are, if the number of constants to be eliminated is greater than the number of independent variables. Suppose if there are 2 independent variables x and y, and there are 3 constants to be eliminated A, B, C, then the elimination of the constants will give rise to a partial differential equation of second or higher order. And then suppose if there are 3 constants to be eliminated and the number of independent variables are x and y, z is a dependent variable because z is a function of x and y. Z is depending on x and y. So z is called the dependent variable and x and y are called the independent variables. So if there are 2 independent variables and there are 3 constants to be eliminated, then the formed differential equation is of order second or higher order, and it is not of first order. That is the observation. You keep in mind, suppose if the number of constants and number of variables, independent variables are same, then the obtained equation is of first order. If the number of constants are greater than the number of independent variables, then the obtained partial differential equation is of second or higher order. That is the observation which we noted in the previous examples by forming the differential equation. And we do one more problem here. Form the partial differential equation by eliminating the arbitrary constants a, b, c from x square by a square plus y square by b square plus z square by c square is equal to 1. So here there are 3 constants to be eliminated and there are 2 independent variables x and y. So the obtained equation will be second or higher order. If these two are same, then the order of the equation, partial differential equation will be 1 only. So we do the same approach. First consider the given equation x square by a square plus y square by b square plus z square by c square is equal to 1. Here we have 3 constants to be eliminated, that is a, b, c. So the number of constants to be eliminated is greater than the number of independent variables x and y, which is only 2. So what we have to do procedure is, first we have to differentiate equation 1 partially with respect to x as well as y. So first we do the partial differentiation, 2x by a square. So with respect to x means second term full 0. Third term will be 1 by c square constant, z square derivative 2z into dou z by dou x, because z is a function of x and y. So z is having the terms x and y. So it is applicable to differentiate in both x and y terms. Dou z by dou x is equal to 0, or on taking out 2 and on writing outside, we will get x by a square first term plus z by c square into dou z by dou x is p. P means it is dou z by dou x and q means dou z by dou y. That is the notation which we are following throughout the chapter. So x by a square plus z by c square into p is equal to 0. Called this is equation number 2. Now similarly on differentiating equation 1 with respect to y. So with respect to y, what we will get? With respect to y, 1 by b square into 2y plus 1 by a square, x by a square, this term will become 0. Second term 1 by b square into y differentiation, y square differentiation 2y plus 1 by c square. First term is 0, that I am not writing here. I am differentiating x square by a square plus y square by b square plus z square by c square is equal to 1 with respect to y, partially. So first term 0. Second term 1 by b square into y square derivative 2y plus 1 by c square into z square derivative 2z into dou z by dou y is equal to 0. So on taking 2 outside, the value y by b square plus z by c square into q is equal to 0, where q is equal to dou z by dou y. So this is called equation number 3. Now from the equations 2, 3 and 1, it is not possible to eliminate the constants A, B, C. We require one more relation. That means you can differentiate equation 2 or equation 3 with respect to x or y. Now I would like to differentiate the equation 2. What is equation 2? So I will show that. The equation 2 is this is. We have to differentiate partially equation 2 once again with respect to x. So on differentiating, what is the equation? X by a square. X by a square plus z by c square into p is equal to 0. So I would like to differentiate equation 2 with respect to x again. So on differentiating x1, 1 by a square will be the first term. And it is 1 by c square constant. I will write here 1 by a square first term. And 1 by c square is constant. And z differentiation with respect to x, dou z by dou x, and p treating as constant term. It is UV form. Because both are having x terms. Z is a function of xy. P already it is dou z by dou x. So P write as it is. Then Z treat as constant term. On differentiating P, you will get dou by dou x of P. Dou P by dou x is equal to 0. Or what I can write 1 by a square plus 1 by c square into, this is what P means, dou z by dou x. This is what I have written, P by c square dou z by dou x plus z by c square into dou P by dou x is equal to 0. That is the equation we have obtained. Already I have written here 1 by a square plus P by c square into dou z by dou x plus z by c square into dou P by dou x is equal to 0. Now, what is dou P by dou x? Dou by dou x of dou P by dou x. Here you can observe that dou P by dou x. Dou P by dou x means dou P by dou x means dou by dou x of P means dou z by dou x. That is what? Dou square z by dou x square. That means what? The value is equal to R. Dou z by dou x square means dou square z by dou x square. That is R. So what I can write is 1 by a square plus P square, P by, what is this is P square or P by C square. Am I right? P square or P? You write it is P. Dou z by dou x also P. Dou z by dou x also can be replaced by P. So what you have obtained is P square by C square, second term. And third term, what is third term? Z by C square as it is, dou P by dou x is R. Dou P by dou x is equal to R. So that will be Z by C square into R is equal to 0, where R is equal to dou square Z by dou x square. The notation which we are following is P, Q, the notation P, Q, R, S, T. P means dou Z by dou x. Q means dou Z by dou y. R means dou square Z by dou x square. S means dou square Z by dou x dou y. T means dou square Z by dou y square. These are the notations which we are following throughout the chapter. So here dou square Z by dou x square is replaced by R. So the equation, this is equation number 4. Now what is our target? We have to eliminate the constants A, B, C. So that can be done by using equations 4 and 2. Already we know that this is 4. Already we have seen what is the equation number 4. 2x by a square, equation 2x by a square plus z by c square into p is equal to 2. This is equation number 2. Already we have seen the differentiating partially with respect to x, we get this equation. So this and this we are using to eliminate the constants a, b, c. So how you are eliminating is multiply the equation 4 by x. Multiply this with x and subtracting 2 from it. On multiplying with this x, you will get x by a square, xp square and zx by c square into r. Am I right? So I am writing here x by a square plus p square x by c square plus rz x by c square minus of this equation is equal to 0. So multiplying with x equation number 4 and on subtracting from it 2 from it, you will get x by a square cancel. And what is you will get c square. C square also will be eliminated. 1 by c square is constant term, common term. You will get p square x plus rzx minus zp is equal to 0. So on writing C square, you will get P square X plus Z or XZ or is equal to PZ. So this is the required partial differential equation on eliminating the constants A, B, C. So this is a second order differential equation. Am I right or not? This is a second and higher order. Whatever it may come, Z into this is dou Z by dou square Z by dou X square. So there is a higher order term dou square Z by dou X square, second order. So the differential equation is not, order is not 1. It is a second or higher order differential equation. So which is the required partial differential equation of order. So this is the elimination of arbitrary constant, where we are eliminated here is 3 constants with 2 independent variables. Now the elimination of arbitrary functions to form partial differential equation. Elimination of arbitrary constants to form PDE. So already we have seen 2 problems in the previous video. Now also we would like to do some problems on the elimination of arbitrary functions also. So far we have eliminated only arbitrary constants. In these problems we are intended to eliminate the functions, the small f and small g like that, or phi 1, phi 2 like that. So see the problem number 1. Form the differential equation by eliminating arbitrary function from z is equal to, what is the function? F of x plus e power y into g of x. So we have to eliminate the arbitrary functions f of x and g of y, or g of x. F of x and g of x. You have to eliminate f of x and g of x, and you have to form the partial differential equation after elimination. So as usual, differentiate with respect to x and differentiate with respect to y, z. So given equation, first write f of x plus e power y into g of x. Call this is equation number 1. And differentiating equation 1 partially with respect to x as well as y, we get dou z by dou x. So differentiate this with respect to x, dou z by dou x. F of x means you will get f dash x plus e power y constant term because it is a function of y, and g of x derivative g dash x. That is the equation number 2. Dou z by dou x means p is equal to f dash x plus e power y into g dash x. This is called equation number 2. And similarly, on differentiating with respect to y, dou z by dou y is equal to, this is a pure function of x, that will be 0, plus e power y differentiation, e power y as it is, g of x is constant function. We treat, because it is differentiating with respect to y, g of x treat as a constant term function. So you write g of x as it is, or q is equal to e power y into g of x, and call this is equation number 3. So just I am rewriting. Now we have to eliminate the functions f of x and g of x. So with the help of these equations, we cannot eliminate. We can replace in the first equation, e power y into g of x is replaced by q. But what about f of x? So f of x cannot be replaced. So, but that's why you have to differentiate equation 2 or 3 again on differentiating. And differentiating equation 3 partially with respect to y. You can do first equation or second equation. On doing the differentiation partially with respect to y, we get this, consider this equation. What is the equation? This is q is equal to e power y into g of x. And differentiating value, what you will get? Dou square z by dou y square. Dou square z by dou y square is equal to e power y as it is, g of x is constant. But what is from equation 3? From equation 3, e power y g of x is same as dou z by dou y. Here e power y into g of x is dou square z by dou y square. So from the above 2 equations, we can write the left hand side terms are equal, dou square z by dou y square is equal to dou z by dou y. So which is the element of f comma g. So in this you can observe that there is no f term, there is no g term. So already the 2 terms were eliminated, the 2 functions were eliminated, and we have obtained an equation dou square z by dou y square minus dou z by dou y is equal to 0. So what is dou square z by dou y square? That is t. Dou z by dou y, that is q. So t minus q is equal to 0. is the required partial differential equation. If it is not possible to eliminate the functions f and g with respect to the given equations 1, 2, 3, then you have to form the another equation by differentiating equation 2 or 3 partially with respect to x or y. So that you can do at your own. No problem. You have to solve the equation and you have to eliminate the constants or functions of x or function of y and form the differential equation. So here I am writing a small observation. If the given relation between x, y, z contains two arbitrary functions, so what are the arbitrary functions f comma g, and the constant variables are x, y, z. X, y, z means z is a function of x and y. Then leaving a few exceptional cases, the PDEs of higher order will be formed. So in some cases there exists a first order equation, or in other cases there is second and higher order differential equations will be formed. Are you getting my point? If z is a function of x and y, that means there are two independent variables and you are supposed to eliminate the two arbitrary functions f comma g. In few cases, except the obtained differential equation will be the second or higher order than the second. The higher order than the second will be formed. PDEs of higher order than the second. So not second, it will be formed higher order differential equation will be obtained. This is only for observation. Right? Now we do another problem by eliminating the arbitrary functions only. Form the partial differential equation by eliminating arbitrary functions phi 1 and phi 2 from z is equal to phi 1 of x plus iy plus phi 2 of x minus iy. So you have to form the differential equation by eliminating arbitrary functions. In the previous example, we have eliminated the functions f comma g. Here you have to eliminate phi 1 comma phi 2. These are the two functions which are to be eliminated from the given function z is equal to phi 1 plus phi 2. So where phi 1 is a function of x plus iy and phi 2 is x minus iy. And before differentiating, I am assuming that x plus iy is equal to u and x minus iy is equal to v. Then what is dou u by dou x? Dou u by dou x is 1 and dou u by dou y is equal to I. Similarly, dou v by dou x, that is 1, and dou v by dou y, this is equal to minus I. So these values will be used in the later case because we are going to differentiate with respect to x and y simultaneously. Now write the given equation z is equal to function of u, phi 1 of u plus phi 2 of v, and call this is equation number 1. Now I want to differentiate partially with respect to x and y. Then you get it. On differentiating with respect to x, dou z by dou x is equal to dou z by dou x. This is on differentiating dou z by dou x is equal to. So phi 1 differentiation, phi 1, u is a function of x and y. Am I right? And v is also a function of x and y. So phi 1 dash into, so dou phi by dou x, dou phi 1 by dou x, or dou u by dou x. What I am writing here, I can see, because u is a function of x, we have to write dou u by dou x. Similarly, phi 2 dash into phi 2 also a function of, so v is a function of x and y. Phi 2 of v means it is a function of x and y only. So phi 2 dash into this is dou v by dou x. So what is the phi 1 dash? Dou u by dou x, that is 1, plus phi 2 dash into dou v by dou x. Dou v by dou x is also 1. So this is phi 1 dash plus phi 2 dash. I will show that. Dou z by dou x is, dou z by dou x means, this is dou z by dou x is equal to phi 1 dash of u plus phi 1 dash of u. Phi 1 means, phi 1 dash means, phi 1 is a function of u comma v. Phi 1 is a function of u, phi 2 is a function of v. So phi 1 dash of u plus phi 2 dash of v. Similarly, on differentiating again with respect to x, dou square z by dou x. This is dou z by dou x. I am going to differentiate one time partially with respect to x. Dou square z by dou x square is equal to phi 1 double dash of u into dou u by dou x plus phi 2 double dash of v into dou v by dou x. Then it is phi 1 double dash of u, dou u by dou x is 1. Dou v by dou x also 1. It is phi 2 double dash of v. We'll call this is equation number 2. So what here I have done is, I have considered the equation z is equal to phi 1 of u plus phi 2 of u, and I consider the derivative with respect to x, dou z by dou x. Similarly, we differentiate partially with respect to y, then dou z by dou y is equal to phi 1 dash of u into dou u by dou y plus phi 2 dash of v into dou v by dou y. That is, phi 1 dash of u is I. Phi 1 dash of dou u by dou y. What is dou u by dou y? I can show here. Dou u by dou y. Dou u by dou y. That is I. Just replace I into phi 1 dash of u and dou v by dou y. What is dou v by dou y? Dou v by dou y is minus I. So what I can write is minus I into phi 2 dash of v, or I into phi 1 dash of u minus phi 2 dash of v. That is the dou z by dou u. This is dou z by dou y. Dou z by dou y. Similarly, dou square z by dou y square. So I'm differentiating again with respect to y. So this is phi 1 double dash of u into dou u by dou y minus phi 2 double dash of v into dou v by dou y. But dou u by dou y is equal to I. This is I into dou u by dou y. This is I. Already this is I is before that. So I into I. This is I. Dou u by dou y is I. And dou v by dou y. Dou v by dou y is minus I. So on replacing, you'll get I into I square. I square means minus 1. So minus phi 1 dash of u. And it is I into I square, minus 1 plus 1. And minus already there, minus phi 2 double dash of v. Right? So from the equations 2 and 3, this and this. So what is the second equation I will show? This is, what is second equation? Dou square z by dou x square is equal to phi 1 double dash of u plus phi 2 double dash of v. So in adding dou square z by dou x square to dou square z by dou y square, the sum is equal to 0, and which is the required partial differential equation. So with the help of the elimination of the arbitrary constants and arbitrary functions, we can form the differential equations of second and higher order and ordinary differential. That means what is first order differential equations also. And these problems have taken from the book of Dr. T.K.V. Iyengar, B. Krishna Gandhi, S. Ranganathan, M.V. S. Prasad, a textbook of engineering mathematics, volume 2, page numbers 161 to 168, and the publishers S. Chandra Company Limited. The publisher, the year book is 2001. So, these few problems, I conclude my lesson. So, thank you.
Like, share and subscribe. Hit the bell icon for more updates.